Welcome back, 7th grade. Good to have you. Always better when you're here. Today I want to teach you how to compare likelihood in two data sets. So make that the title on the next free page in your math notebook. When you've done that, mark your page with a pencil, close it up, give me all that brain power till it's time to write. All right, a couple things to remind you of. We reviewed turning data sets into box and whisker plots and box and whisker plots back into data set. So I just want to bring that back to mind, kind of the way that we did that so that you know. To make the box and whisker plot, we found the median and then the median of the lower part and the upper part to make that. And then from the box and whisker plot to make a data set, we can know the minimum value, we can know the maximum value, we can know the median value. It's between probably 7 and 8 here, but we can't know all of the values, but we did find ways to know a lot of them. So I just wanted to call that back to mind. Another word in the title, you'll notice we're going to compare likelihood into data sets. Let me remind you what those words mean in math. Compare in math doesn't mean the same thing it means elsewhere. It usually means when we're comparing values. So we talk about things being greater or less or equal in value when we're comparing, sometimes with those signs too. So we talk about comparing in math, that's what I'm talking about. And then likelihood we talked about, I think, on the very first day of school this year. Those were things like impossible and unlikely. We learned how to evaluate those things. Equally likely as not, equally likely as not, likely and certain. So that's kind of where we've been so far and stuff that's going to come back today that I wanted to bring to mind. So let's look at an example where we compare likelihood in two data sets. So take a look at this one. In college, you have to buy your textbooks. Yes, really. And they cost a lot. Also, really. Oh, that's true. So here's the box and whisker plots showing the prices of textbooks at two different stores near the same college. Check it out. At which bookstore are you more likely to get a better price? That's what we're going to answer. Notice it says more likely to get a better price. Because when you look here, they have a big range of prices at both bookstores. So the question just becomes, hey, which one's more likely to have a better price? So let's look at ways we can do that. I'm going to go to a new slide without the top part, just so I have more space to write. Sorry. All right, so if you remember when we make box and whisker plots, they have 5 sort of key places on them. The lower extreme, so in this case, that's the cheapest book at each store. The lower quartile, it's called that. So that's where 25% of the data is. So there's, if you remember how box and whisker, whoop, wrong button, sorry. If you remember how box and whisker plots work, each part of the box and the whisker is 25% of the data, right? 25%, 25%, or 1/4, 25%, or 1/4, 25, right? So that extreme, that lower quartile rather, means sort of like 25% of the data is below that point. 1/4 of all the books cost less than, and this one about $71 or $72. Then there's the median of the data sets right here. So that's the 50% point. So in this case, 50% of the books at this store cost less than about $90 and 50% cost more. Man, these books are expensive in college, y'all. No joke. And then similar thing is the upper quartile right here. So that is sort of 25% is this way, and the other 75% is this way. So 25% of the books cost more than $110, 75% cost less. And then, of course, we have the upper extreme, which is the most expensive book at each store here. So I want to look at all 5 of those and see if they give us any clue of where I'm likely to get a better price. So then let's start, since we're looking at cheaper, we want to know which one's cheaper. We kind of want to look backwards. So let's start with the most expensive. So at store A, versus store B, we could say that the most expensive book, and we could compare that. So, and the most expensive means all of them are less than this. So at store A, the most expensive book appears to be about $110, and at store B, the most expensive book appears to be about $120. So off the bat, feels like store B is more expensive and for store A is less expensive. All of the books at B are under 120. All the books at store A are under 110, or at 110, I should say, less than or equal to. So that's one way you can look at it. Let's keep working our way back. Let's now look at the 75% point. So 75% is called the upper quartile. You want to think about that term. So if I look at the upper quartile of each, here we go. So it looks like at store A, somewhere around, $104, $105. I'll just say 104. Store B, $110. So already also still there. So what that means, remember that point means at each store, 3/4 of the books, or 75%, cost less than that. 1/4, 25% cost more than that. So as I start to look at that, now I'm really, at least for now, feeling like store A is cheaper because look at this. At store B, 1/4 of the books cost $110 at store B. That's a lot, 75%. Only one book at store A costs $110. So that's like 75% of the books at store B are as much as the most expensive book at store A. So I'm really starting to see that line up. So right now, at least what I've seen so far, store B is feeling a lot less expensive. Let's look at the median, or the 50% point. So at store A, we're starting to get a difference here. So at store A, looks like half the books are $95 or less, half the books are $95 or more. Store B, now we've kind of maybe gone less here. Now we're to store B is only 90. So at first it was starting to feel like store B was more expensive because it was more here and it was more here. But now store B is looking like it costs less at the median. So there's a lot of books in store A right here. 1/4 of their books are between $95 and $105. Let's keep going down. Let's go to the lower quartile, 25% of the books. I'll just write lower Q, lower quartile. So at store B, store A rather, I'm sorry, it looks like 25% of the books are less than, it's hard to tell, 87 maybe? Store B, 25% of the books are less than like 72 or something. So now at this point, the cheaper books at store B are way cheaper than the cheaper books at store A. So this is kind of an interesting comparison to make. Because the store B, when we were kind of looking at the more expensive books on the end, store B was a lot more. But now as we get to the cheaper books, it's starting to look like it's reversing and store B is less. Pretty interesting. And then, of course, we can look at the least expensive. That's called, where all the books are more than that. The cheapest book at store B is about $60. The cheapest book at store A is about $75. And it looks like we have a pretty mixed result. Which books are cheaper? It really varies a lot in this case. So if we look, back here, looks like the expensive end of the books were cheaper at store A, but then the cheaper end of the books were cheaper at store B. So I would say we kind of have a mixed result in comparing these. And you would need to explain it like I have there. So I sort of like to say, yeah, if you look at the cheaper books, they're cheaper at store B, but the more expensive books are cheaper are at store A, and the more expensive books are more at store B. So it really kind of varies a lot here. And if you look at these, it kind of can tell. If you start to compare each point on their box and whisker, you can tell what direction has the more expensive store. So it's a really careful analysis since all the books don't cost the same amount. And you've kind of got to look at a lot of points, and sometimes it's not super clear which one's more or which one's less, but a cool way to look at it. Let's do one together. I may have to ask you to pause. I'm running out of time pretty quick here. Go ahead and write this one down and unpause, and then we'll work through this one in the same way. Oh, I need to add what these are called. Sorry, this is going to be store A, and this is going to be store B. All right, at which store are you likely to get out of there in a faster amount of time? So let's take a look. We'll compare store A and store B. So let's start with the faster is shorter on time. So let's start at the top. Let's start with the longest you might have to visit. So the longest visit to store A was about 65 minutes. And the longest visit to store B was about 66 minutes. So slightly longer for store B, but hardly made a difference. Let's now look at 75% of your visits. That's called the upper quartile. Quartile, Q-U-A-R-T-I-L-E. So at store B, 75% of the visits were less than, let's call that 59 minutes. And at store A, 75% of the visits were less than 55 minutes. So far, store A is faster on both measurements that we've checked so far. Let's try the median. So that's like the middle length, 50%, or the median. Store A, half the visits were less than 48 minutes. And here we're starting to have a big difference. Look how much difference there is in these medians. 40 minutes, half the visits were less than 40 minutes at store B. So we've kind of reversed again. 25% of the visits are lower quartile. Store A, 25% of the visits were less than 30 minutes. And store B, 25% of the visits were less than about 32 minutes. And then the shortest or the fastest visit, that's called the lower extreme. Store B, the very fastest visitor was, looks like about 8. And store A looks like about 5. So again, we have a mixed set. So let's kind of look. It looks like store A was faster here, was faster here, was faster here, and was faster here. So I would say this one is more clear that store A is likely to be faster. Not for sure, right? You could still end up anywhere on this table or anywhere on this table, but I would say here store A is most likely to be faster. If that made some sense to you, here's how you can know if it did. If I gave you 2 new box and whisker plots, could you compare the minimums, the maximums, the 25% mark, the 50%, and the 75% mark to make a reasonable judgment of which of the 2 box and whisker plots showed more or less or faster or shorter or higher or lower data? Most likely gives you things to compare. If not, please go back. This is a very new and very kind of advanced concept. Please just go back, watch this again. I think it'll help you feel more confident when you get class tomorrow. If you do feel good about this after these 2 examples, I will see you tomorrow, and I think you're all set.